Okay, in this lesson we're going to be learning how to calculate probabilities on events when they are either dependent events or independent events. So first we're going to talk about the differences between independent and dependent events, and then we're going to talk about how we determine probabilities based on the types. So let's talk about independent events. These are events that have no impact on another event. Meaning, let's take for example flipping a coin 2 times. The first toss of a coin does not affect the second toss, so we say that flipping a coin twice, we say that the first event is independent of the second event. Same thing with a spinner. Say we spin a wheel. How we spin it the first time, what we get on the first spin has no bearing on what we get on the second spin. So we say they're independent events. They're dependent when the event affects the following outcome of some other event. So for example, say we pick a card from a deck and then we pick another one from that same deck without putting that card back, the first card back. That's a dependent event, the second one. So here are some following ones. Why don't you decide if they are dependent or independent, and then I'll talk about it. So stop the video, think about it, and I'll talk about it right now. Rolling a dice 2 times, independent. First one does not affect the second throw. Choosing a marble from a bag and then choosing another colored marble from the bag. I'll say this is dependent. This is assuming that we did not put the first marble back into the bag. So after we pulled one marble out, it changes the bag, and then pulling the second one then depends on what happened when we pulled the first one out. 2 students' birthdays, independent. Doesn't matter when the first person was born, the second person is born independently of the first person. We'll talk about this problem, this D in class tomorrow. Probability of independent events. Let's consider 2 events, having a baby boy or having a baby girl. And they're independent events in the fact that whether you first had a baby boy, having another child doesn't matter whether you had a boy or a girl before that. So then the probability of having a boy and then after getting a girl would be the probability of getting a boy times the probability of getting a girl, which would be 1/2 times 1/2 is equal to 1/4. So the key idea here is that when 2 events are independent of each other, to find the probability of both events happening, A and B, we can merely multiply the 2 separate probabilities of each event together. So here's an example. You enter into 2 contests. The first contest had 100 raffle tickets sold, and the second contest had 200 raffle tickets sold, and they're independent events. So the probability of winning both is equal to the probability of winning the first one multiplied times the probability of winning the second one. So that would be equal to 1 over 100 times 1 over 200, which is equal to 1 over 20,000. Here's another example. The probability of someone in a group of 5 being born on April 15th. Now, each person is independent, right? The day one person is born is independent on the day another person is born. And we're going to use the complement kind of method to solve this one. We're going to say that the probability of someone in a group of 5 being born on 4/15 is equal to 1 minus the complement, where no one is born on 4/15. So to think about that, we say, well, what's the probability of one person being or not being born on 4/15? There are 364 days other than 4/15 out of a total of 365. and then we raise that to the 5th power because there are 5 people in the group. So we can, multiply each of the 5 probabilities. Probability of the first person not being born on 4/15, the probability of the second person not being born on 4/15, probability of the third person not being born on 4/15, and so on. So we raise that to the 5th power. 1 minus that is equal to 1.4%. Okay, let's talk about conditional probability, the probability of an event after an event A. So this is how we write it. Probability of B, event B, after event A has happened. So here's an example. The probability of drawing a 7 after we've drawn a jack from a deck of cards. That would be 4 out of 51 because after we've pulled a jack, there are now only 51 cards in a deck. There are still there are still 4 sevens, so the probability would be 4 out of 51. Let's look at the probability of choosing a jack after drawing a jack, and we write this as probability of J, and we have a bar. This is not division here, okay? J after J, jack after jack. In this case, after we've already drawn a jack, there are only 3 jacks remaining, and there are only 51 cards remaining. So in this case, the probability is 3 out of 51. Okay, finally, let's talk about dependent events. So dependent events, again, are events where the following event depends on the first event. So let's talk about this, where what is the probability of drawing a jack and then a 7? And the key is afterwards, after we've drawn a jack, then we draw a 7. So let's just talk about the probability of drawing a jack. That's 4 out of 52. Then after that, let's consider what happens after we've already drawn a jack, and this is the way we write that. Probability of drawing a 7 after drawing a jack is 4 out of 51. So then, combining the two, the probability of drawing a jack and then, actually let me put that in here, and then a 7 would be 4 out of 52 times 4 out of 51, which is approximately 0.6%. So here's the key idea here. The probability of A and B is equal to the probability of A times the probability of B after A, you could say. So here are some practice problems that you can try out, and we'll go over them the next time we get together. Let me just talk about quickly the first one, spinning a wheel. Is it independent or dependent? Think about that first. Second one here, given a bag of marbles, find the probability of choosing a blue marble and then another blue marble, and for this one, assume that we do not replace the marble back into the bag after we've chosen one. Okay, that's the end of our lesson.